Imagine waking up one morning and learning that a colossal object, originating from another star, not only passed close to Mars but that images of its trajectory could transform the history of astronomy, and someone is trying to conceal them. Picture a comet, arriving from interstellar space, visiting our cosmic neighborhood and captured by multiple spacecraft orbiting the red planet. Envision that these photographs might reveal clues about the nature of an enigmatic visitor that challenges our most fundamental theories, yet the space agency holding this data refuses to share it. If this sounds like the premise of a science fiction film, wait until you hear all the details. I am a scientist who has dedicated my life to studying the cosmos and tracking wandering objects that traverse our solar system. What I am about to tell you about 3I Atlas, a comet from another star system, and the images captured from Mars is real, documented, and at the same time, astonishing. It is a story of one anomaly after another, perplexing decisions by space agencies, and questions we have yet to resolve. The origin of this narrative dates back to the 1st of July, 2025. On that day, the Atlas asteroid warning system detected a bright point moving at high speed across the sky. By calculating its orbit, astronomers determined that it followed neither a circle nor an ellipse, but a hyperbola. This indicated that the object was not gravitationally bound to the Sun. It came from beyond the solar system and would pass through only once. We classified it as the third interstellar visitor, following Oumuamua in 2017 and Borisov in 2019. It was designated 3I Atlas. Unlike Oumuamua, detected as it was already departing, and Borisov, spotted with little time to spare, 3I Atlas was identified several months before its closest approach to the Sun. This allowed for the organization of its tracking, the planning of observations, and the preparation of missions. The scientific community was thrilled, as we could study a messenger from other stars in detail. From the outset, the characteristics of 3I Atlas were extraordinary. Its speed exceeded 130,000 kilometers per hour. Its size, though uncertain, appeared to reach several kilometers in diameter, possibly 5 or more. This volume, combined with its velocity, made it the largest and fastest interstellar object ever observed by humanity. Calculations showed that its orbit was inclined only a few degrees relative to the ecliptic plane, the band where the planets orbit. This meant its trajectory would cross our solar highway. Following this path, it would approach Venus, then Earth and Mars, and finally head toward Jupiter before exiting the system. This was a statistically improbable coincidence, so much so that many scientists deemed it an anomaly worthy of study. But this was only the first of many. The second anomaly became evident when the first telescopes were aimed at the comet. Known comets typically display a tail of gas and dust pointing away from the Sun, driven by the solar wind. However, images of 3I Atlas, captured by the Hubble Space Telescope and the Gemini Telescope, revealed a jet of material directed toward the Sun. This was termed an anti-tail. Initially, it was thought to be a perspective effect, with previously ejected particles crossing our line of sight. But spectra confirmed a real flow of carbon dioxide and carbon monoxide emanating from the illuminated hemisphere. This behavior does not align with most comets observed in our solar system. Thus, the anti-tail joined the list of peculiarities. The third anomaly emerged when studying the comet's mass. The amount of ejected gas and the pressure of solar radiation suggested that 3I Atlas possessed a colossal mass, far exceeding that of known comets. Estimates pointed to tens of thousands of billions of tons. Such a heavy object would require an enormous nucleus or a surprisingly high density. This mass, combined with its speed, implied that 3I Atlas had sufficient inertia that gas jets would not significantly alter its trajectory. Some researchers wondered how such a massive object could have formed in interstellar space, where material density is extremely low. This enigma remains unanswered and is one of the most intriguing questions. The fourth anomaly concerned the comet's chemical composition. Comets in our system are primarily composed of water ice, with lesser amounts of carbon dioxide, carbon monoxide, and other compounds. In 3I Atlas, water was only a minor component. Observations conducted by ground-based telescopes and the James Webb Telescope detected an excess of carbon dioxide. Measurements showed that the ratio of carbon dioxide to water was nearly 8 times higher than in local comets. Additionally, spectra revealed the presence of nickel vapors and a compound known as nickel tetracarbonyl. This compound is common in industrial metal refining processes on Earth, but was unexpected in a natural comet. The absence of iron in typical proportions relative to nickel heightened the surprise. This suggests a distinct chemical origin or an unusual formation environment. Such characteristics led some scientists to speculate that the comet may have formed close to its parent star, in regions where water could not freeze, or was subjected to processes that radically altered its composition. The fifth anomaly was detected through the analysis of the polarization of light reflected by the comet. In typical comets, sunlight is positively polarized. In 3I Atlas, an extreme negative polarization was observed. This polarization implies that the structure of dust particles in the coma differs significantly from known comets. These could be hollow, porous, or unusually shaped particles that alter the orientation of light in distinctive ways. This reinforced the image of a chemically and physically exotic object. The sixth anomaly was tied to the coincidence of its trajectory with the timing of its passage near several planets. Its path led to an encounter with Venus, then Mars, and finally Jupiter, all within a relatively short time frame. To some, this sequence seemed almost orchestrated, like a tour of the solar system. To others, it was an improbable but not impossible coincidence. In any case, it became another piece of the mosaic of peculiarities that made 3I Atlas an object worthy of attention. The seventh anomaly concerned the direction of the comet's arrival. It approached from a region of the sky close to the location of the famous WOW signal detected in 1977, a mysterious radio burst of unknown origin. This geographical coincidence, though likely fortuitous, fueled the imagination of those seeking connections between phenomena. The eighth anomaly was a non-gravitational acceleration detected by NASA's Jet Propulsion Laboratory. Calculations showed that the comet's velocity varied in a way that could not be explained solely by the gravitational pull of the Sun and planets. If this acceleration was due to gas ejection, it would imply that the comet was losing a significant portion of its mass in a short time, which was not directly observed. This acceleration piqued the interest of those who considered that another mechanism might be at play. With all these peculiarities in mind, the scientific community eagerly awaited the moment when 3I Atlas would pass by Mars. It was not a close encounter in absolute terms. The minimum distance was about 30 million kilometers. However, from an observational perspective, it was a unique opportunity. Mars hosts several orbiting spacecraft equipped with cameras and spectrometers. Among them are the Chinese Tianwen-1 probe, the European ExoMars Trace Gas Orbiter, and the venerable Mars Express. Each could direct its instruments toward the comet and capture images and data unattainable from Earth. The first probe to report observations was the Chinese Tianwen-1. According to Chinese media, the probe captured images of 3I Atlas during its approach to Mars. The photographs show a solid nucleus surrounded by a halo of gas and dust, with the characteristics of an active comet. Although the comet appeared as a bright point in space, the images clearly displayed the glow of the coma. These photos, disseminated by the Chinese press, generated significant interest. It was noted that these were the first close-up images of an interstellar comet taken from another planet. Earth was in solar conjunction, and ground-based telescopes could not observe it, making the Martian images valuable. Meanwhile, the European ExoMars Trace Gas Orbiter mission, equipped with a Cassis camera, directed its lens toward the comet. This camera captured several sequences between the 1st and 7th of October, 2025. In the photographs, the comet appears as a blurred point, a sort of white smudge at the center, surrounded by a subtle halo. The Cassis camera could not distinguish the comet's nucleus from its coma, as the nucleus was too small and faint at that distance. A scientist from the European Space Agency likened it to trying to see a mobile phone on the Moon's surface from Earth. The coma was visible, but no tail was detectable. At that moment, the solar wind may not have generated a noticeable tail, or it was aligned with our line of sight. The European Space Agency explained that the coma was visible, but the tail was too faint to be noticed. Nevertheless, those responsible for Cassis were thrilled. It was the first time the camera had captured an interstellar object. The data became a treasure for scientists. Simultaneously, the Mars Express mission attempted to capture images with its high-resolution camera. Mars Express is equipped with several cameras, including the HRSC, but their exposures were shorter and not always aimed at the comet. Scientists from the European Space Agency noted that they had not yet located the comet in Mars Express images. They planned to combine multiple exposures to enhance sensitivity and detect the comet's faint signal. They also attempted to obtain spectra using the Omega, SPICM, and NOMAD instruments to analyze the composition. However, it was unclear whether the comet was bright enough for spectral characterization. The European Space Agency emphasized that watching these missions respond to the passage of an interstellar comet was thrilling and demonstrated the orbiter's ability to react to unforeseen events. It also highlighted that 3I Atlas was only the third observed interstellar comet and likely billions of years old, possibly older than the solar system itself. These images from Tianwen-1 and ExoMars sparked significant excitement. They not only provided scientific data but also ignited the collective imagination. Talk of the first photographs of an interstellar comet taken from another planet spread, and the images were shared on social media. The discussion intensified when it was learned that several NASA missions had also pointed their cameras at the comet but had not released the results. The Mars Reconnaissance Orbiter and the MAVEN probe are equipped with cameras and spectrometers capable of capturing such events. According to sources within the United States government, it is presumed they took images and gathered data, but these have not been made public. Various websites began speculating about why NASA was not releasing high-resolution images. Some argued that NASA was waiting to process them to ensure they showed something significant. Others, more skeptical, claimed NASA was concealing information. This coincided with an administrative government shutdown in the United States, which delayed updates and official communications. The coincidence of the solar conjunction, the government shutdown, and the absence of images fueled conspiracy theories. An article in India Today reflected this public pressure. It quoted Congresswoman Anna Paulina Luna, who urged NASA to release the high-resolution images captured during the Mars approach. She argued that citizens have a right to know and that the images could reveal physical phenomena never observed before. The article emphasized that 3I Atlas was a unique comet and that the data could transform our understanding of interstellar objects. It insisted that NASA should not delay the release of the images. Additionally, it mentioned that the comet had shown unexpected non-gravitational acceleration and an increase in brightness as it approached the Sun. This fueled the narrative that the images might contain evidence of strange phenomena, perhaps even non-human technology. As a scientist, I strive to analyze the facts before succumbing to speculative conspiracy theories. NASA, like any agency, has protocols. It must process and calibrate data before publication. If the government is shut down, the personnel responsible for communications may be unavailable. However, I understand that a lack of transparency breeds suspicion. NASA faces a dilemma: release raw images that could be misinterpreted or wait for proper analysis and face accusations of concealment. In the case of 3I Atlas, the agency opted for caution. This created a vacuum that was filled with hypotheses. Meanwhile, the international community mobilized to fill this void. Images from the European Space Agency and Tianwen-1 became a window onto the comet. Although not as detailed as desired, they confirmed the presence of a nucleus surrounded by a glowing coma. Scientists analyzing these images noted that the nucleus, seen from Mars at a distance of 30 million kilometers, appeared as a smudge, as distinguishing a kilometer in diameter at that distance is akin to trying to see a phone on the Moon's surface. The fact that the coma was visible but the tail was not suggested that the comet was active, but the tail had not yet developed or was oriented differently. This observation supported the theory that the tail might appear with closer proximity to the Sun. In the context of space exploration, this is not the first instance of mission data being published with a delay. When the New Horizons probe reached Pluto, NASA required months to display high-resolution images, as data transmission across the solar system is slow, and files require processing. With the James Webb Telescope, a similar process occurs. Each image undergoes calibration to eliminate noise and interference. In the case of 3I Atlas, the difference lies in the fact that it is an object generating enormous speculation due to its anomalies. This increases public pressure and impatience. Concurrently, other sources of information continued to fuel the mystery. Some websites suggested that the Chinese Space Agency held more images than it shared. Others claimed that the European Space Agency possessed spectra showing unusual compounds, but was reserving them for scientific publications. Rumors also emerged that the images depicted objects around the comet or unexplained light emissions. None of these claims were verified, but the lack of data inflamed the collective imagination. While I passionately enjoy dreaming, I know our responsibility is to distinguish between speculation and evidence. Another pertinent aspect of this story is the geopolitical context. Space exploration is a domain where science, politics, and diplomacy converge. Missions to Mars are conducted by multiple nations. When an interstellar comet passes nearby, it becomes a valuable scientific resource. Each agency wants to be the first to publish data, but also seeks to ensure its results and reputation. In this case, China was able to share its images quickly due to its political framework. The European Space Agency, with its multinational structure, released preliminary images and mentioned that it was processing others. NASA, constrained by an administrative shutdown, could not fully communicate. This landscape fosters theories about hidden interests and competition. However, reality is often more complex and less conspiratorial. Science, bureaucracy, and politics intertwine in ways that sometimes hinder transparency. Meanwhile, 3I Atlas continued to generate news. After perihelion, in addition to becoming brighter and bluer, it was observed that its tail, now visible, did not behave like that of typical comets. The tail pointed in a direction not aligned with the sun's position. This phenomenon was interpreted as an anti-flow, where material is ejected forward due to the nucleus's rotation and uneven distribution of cavities. Some scientists linked this to the anti-tail observed months earlier, while others suggested the comet might be undergoing surface detachment. In any case, the tail's configuration reinforced the idea that we were dealing with an exceptionally unique object. Another topic of discussion was the possible presence of particle clusters or mini-probes around the comet. Some interpreted flashes and dots in the images as evidence of independent objects. The theory suggested that the comet might be releasing small probes to explore the planets. However, imaging specialists argued that these dots were background stars twinkling due to camera motion and the comet's rotation. No objects moving independently around 3I Atlas were detected. Over the months, curiosity did not wane. The comet was described as a black swan, an extremely unlikely event that challenges our expectations. The combination of orbital alignment, reversed jet, enormous mass, carbon dioxide, and nickel-rich composition, negative polarization, coincidence with the WOW, signal direction, non-gravitational acceleration, and color change makes it a unique case. For some scientists, this is an incentive to expand our theories about the formation and behavior of interstellar objects. For others, it is an invitation to hypothesize about extraterrestrial technology. The question of artificiality cannot be dismissed outright, but for now, there is no compelling evidence. Now, what about the images that NASA doesn't want you to see? What happened to the photographs captured by the American orbiters? According to internal sources, the Mars Reconnaissance Orbiter and the MAVEN probe did indeed collect data on the comet. However, publishing high-resolution images involves a complex process of transmission and calibration. Additionally, with the government shutdown, employees responsible for updates were not working. This caused a delay of several weeks. According to subsequent statements, NASA plans to release the images once the analysis is complete. Consulted experts indicated that there is no evidence of deliberate censorship, only an administrative delay. Nevertheless, public perception is already laden with suspicion. Headlines claiming images NASA doesn't want you to see attract more attention than those explaining that data processing takes time. Meanwhile, data from the European Space Agency and Tianwen-1 continue to circulate and spark debates. The CASIS probe from ExoMars, though unable to distinguish the nucleus from the coma, demonstrated the capability of a Martian orbiter to observe external astronomical events. The Chinese probe's images showed a broader audience that there is both cooperation and independence in space exploration. Mars Express's efforts to combine exposures reflect how science perseveres despite limitations. In my view, this episode serves as a reminder of the importance of transparency in science. The public's curiosity is legitimate. The impatience to see new data is understandable. Distrust in institutions can arise when communication is lacking. Space agencies must acknowledge that we live in a world where information spreads rapidly, and gaps are filled with hypotheses. It's not about revealing secrets prematurely, but about explaining processes and required timelines. If NASA had clearly communicated that processing would take time, perhaps conspiracy theories would not have proliferated so much. The media also bear responsibility. Not every silence is a conspiracy. Not every anomaly is extraterrestrial. It's easy to write headlines like images they don't want you to see or NASA in shock, but these claims must be backed by facts. In this case, we know that images of 3I Atlas taken from Mars exist but have not yet been published. We also know that other agencies have shared their data. We know the comet is unique in many respects. What we don't know is whether these images show anything beyond what has been observed. I wager they will show what we already know: a small nucleus surrounded by a halo, perhaps an incipient tail, and possibly brightness variations. I don't believe they conceal ships or structures. But until we see them, doubt will persist. While we await these images, it's worth reflecting on what we've already learned. 3I Atlas has taught us that interstellar objects can be far more diverse than we imagined. It has shown that chemical compositions can include an abundance of compounds like carbon dioxide and nickel, with water being scarce. It has reminded us that trajectories can align in unusual ways and that comets can exhibit jets directed toward the sun. It has forced us to reconsider what processes might generate extreme negative polarization of light. And it has made us view Mars as a platform for observing the cosmos. This is a shift in perspective. We considered Mars a destination, but now the red planet has become a window to an interstellar messenger. There are also lessons about international collaboration. The Tianwen-1 images revealed China's ability to conduct cutting-edge science on Mars. ExoMars observations demonstrated the flexibility of European missions to adapt plans to unforeseen events. Mars Express's efforts to combine exposures show the resilience of long-term missions. And NASA's role, despite the controversy, remains central. If these images reveal anything, it's that science does not advance alone. Data sharing, cooperation, and transparency are essential. If each agency acts independently, the public tends toward distrust. If they work together, the benefit for all is greater. On the horizon, questions remain. What will spectral analysis reveal when NASA and the European Space Agency publish their data? Will the presence of unusual compounds be confirmed? Will we understand why the polarization is so extreme? Will the blue hue and brightness increase be explained? Will we see the full tail? Will the non-gravitational acceleration recur? Moreover, the question of the comet's nature will persist. Is it a natural object with unusual characteristics? Is it a fragment of a larger body ejected from its system? Or is it an artifact? The most provocative question, whether it is a messenger from another civilization, will linger. For now, science does not support the artificiality hypothesis, but the mere fact that it is raised reflects the level of uncertainty and fascination that 3I Atlas generates. For those of us who, like me, dedicate our lives to looking beyond, the story of 3I Atlas is a lesson in humility. It reminds us that the cosmos is vast, and our theories, however robust they seem, are provisional. It teaches us that nature can always surprise us. And it reminds us that human curiosity is indomitable. When someone says an agency doesn't want you to see images, it ignites the mind. Some grow indignant, others become inspired. The key is to channel this curiosity toward knowledge, not superstition. If it's confirmed that NASA delayed publication due to an administrative shutdown and calibration process, we should accept that science has its timelines. But we must not stop demanding transparency and clarity. Personally, I eagerly await the high-resolution images captured by NASA's probes. I am confident that, like the photos from Tianwen-1 and ExoMars, they will show a bright point surrounded by a halo, perhaps an emerging tail. But I also know their true value lies not in a potential visual spectacle, but in the data they provide. Each pixel encodes information about composition, temperature, and dynamics. With this data, we can refine models, discard hypotheses, and propose new ones. And of course, we can silence some voices and make room for others. You may be wondering what to think. Should you believe NASA is hiding a transcendent truth? Should you convince yourself that 3I Atlas is an extraterrestrial craft? Or should you patiently wait for more information? My advice is to maintain a critical mind. Science advances through doubt and discipline. Questioning is legitimate, but it's crucial to distinguish between the improbable and the impossible. A comet can have 9 or 10 anomalies and still be natural. But it can also inspire us to explore the idea that the universe is filled with objects so strange they seem designed. No question should be dismissed as long as the answer is sought with rigor. I've made a tremendous effort to gather and organize this story, examining public data and filtering speculation. I've spoken with colleagues, read articles, and studied the images. While I still don't have all the answers, I can assert that this story is an extraordinary example of how science and culture intertwine. 3I Atlas is an interstellar comet approaching Mars, photographed by multiple agencies, behaving strangely, generating sensational headlines, and at the same time, advancing scientific progress. It's a piece of ice, rock, and gas, but also a mirror in which we see ourselves, eager for knowledge, prone to imagining conspiracies, capable of cooperation and distrust simultaneously. Perhaps the true lesson of this story is that we must communicate science better. If a space agency needs weeks to publish data, it should explain why. If there are anomalies, scientists should cautiously share their hypotheses, avoiding inflaming the public's imagination without evidence. If techno-signatures are discovered, transparency is essential. And if none are found, that too. Ultimately, trust in science is built on honesty. I will continue to tell you everything I learn about 3I Atlas. For now, we know it has become brighter and bluer than ever. We know Martian images exist, and some have been published. We know NASA is processing its data. We know there are unanswered questions, and science does not give up on finding them. If this story has inspired you, if it has awakened your curiosity to look at the sky and wonder what lies beyond, I invite you to share this story with your friends. If it has made you reflect on the importance of transparency and scientific patience, support it and subscribe to our channel. Space exploration is a collective adventure, and knowledge multiplies when shared. 3I Atlas will continue its journey, lost in interstellar space, and likely never return. But its passage has left a mark on our hearts and our science. And we will remain here, observing, questioning, and narrating. For the universe is full of mysteries, and there will always be something someone doesn't want you to see. Or perhaps, more simply, something no one has seen yet.